Hello, so we're doing lesson 6.6. This is a continuation of the previous lesson on trigonometric ratios. As we learned, there are 6 of them total. Each one is a ratio that pairs up sides of a right triangle, so opposite, adjacent, hypotenuse. There's the main 3, sine, cosine, tangent, and then the other 3, which are the reciprocals, secant, cosecant, and cotangent. Today we're going to look at evaluating these trig ratios on a calculator. I'll be using Desmos, and this is going to be done in degree and radians, and that is just going to be easy. You're just going to type, hit buttons on a calculator and get answers. That's about half of this assignment. It's really easy. The other half of the assignment is going to be more of a challenge. You'll be given one trig ratio, and you'll be asked to find another trig ratio. And this is going to involve making a diagram, and we may possibly need to use the Pythagorean theorem as well. So let's go ahead and get started. You can see there's not a whole lot of notes here. This first set, 1 through 12, this is just using a calculator. We're going to round to the nearest 10,000th. So as a decimal, we got our decimal, tenths, hundredths, thousandths, 10,000ths. So everything's going to go to 4 decimal places here. All right, let me go ahead and split the screen and bring up Desmos. And obviously I'm going to do the evens, you do the odds, it'll be very similar. And the first 3 exercises I'm going to do, you notice the degree sign, same for your assignment. That means that our calculator has to be able to handle degrees. So Desmos and most handheld calculators have a setting or an option. Up here in the right-hand corner, there's that little wrench, and if you click it, you get this menu, and down at the bottom, you see radians, degrees, and you can toggle back and forth. Now, the exercises I'm going to do first are measured in degrees, so I have to click degrees before I get going. So there, I got it in degrees, so now I have to do the cosecant of 40 degrees. Now, how do I get cosecant on my calculator? In the bottom right, I'm going to hit the function button. Trig, stats, distribution, miscellaneous. Of course, we want trig. In the left column, about halfway down, you see cosecant. Simply type in 40, and I get an answer. 1.5557. And wouldn't it be great if I had good handwriting? But that's it. We're, not doing high-level math with a lot of calculation and steps and everything. We're just letting the calculator do the work. This is basically training, and I'm training you how to use Desmos to do some trig. So, sine of 75. Function, hit the sine button, 75, 0.9659. That should be the answer. And indeed it is. So just going along nicely. Number 6, cotangent 79 degrees. So function, cotangent is at the very bottom left, 79 right here, 0.1944. That 3 is going to round up to a 4. And there you see the answer. Now this next one I am going to do incorrectly on purpose. I swear to you, I'm not making a mistake. I'm doing this wrong on purpose. So secant of 5 pi over 18. Secant 5 pi over 18. I get 1.0001. I'm not going to circle it because I know it's wrong. You see right there a different answer. So what's the problem? Well, we switched from degrees to radians. How do I know it's radians? Well, because of the pi that's in there. So I need to go back to my calculator and say, hey, I want to do things in radians. So now, function secant 5 pi over 18, 1.5557, and there it is. Now that the calculator is in radian mode, I'm good to go for the rest of the exercises. So function cosine 31 pi over, and I'm using the divide button to get that fraction bar, of course, over 180, 0.8572. That 1 is going to round up to a 2. 8572, there it is. And last but not least, number 12 is a tangent problem. So function, where's tangent? Right there in the middle. Tangent, 13 pi over 180, 0.2309. Again, follow rules of rounding. Make sure you round off correctly, 4 decimal places. So the first half of this worksheet, hopefully you're not going to find to be difficult at all. Should just work right out, no problem. Now for the bottom half, I'm not trying to say that this is going to be difficult, but it is going to be work. So find cosecant of theta if sine of theta equals 3 radical 10 over 10. So how do we do this? Well, first, recall that sine, what's given here, is opposite over hypotenuse. Opposite over hypotenuse. So that means if I draw a right triangle, here's my right angle. This, of course, is the hypotenuse. If I call this theta, this is my opposite, adjacent. So opposite is 3 pi over 10, or 3 pi, why do I keep saying pi? 3 radical 10. Hypotenuse is 10. Now, if we want to find cosecant, what is cosecant? Well, cosecant is defined as hypotenuse over, let's see, over opposite. Cosecant is hypotenuse over opposite. Now, boy, if you remember from the previous lesson, I got really paranoid about forgetting this, so I'm going to go back to the notes from the previous lesson. Yeah, right there, hypotenuse over opposite. So feel free to check your notes as needed. Hypotenuse over opposite. So I just take the hypotenuse, which is 10, over the opposite, which is 3 square root of 10, right? Hypotenuse over opposite. I did not need to do the Pythagorean theorem in this problem. Adjacent did not come into play at all. So I have this answer, although, wait, you can't have the radical in the denominator of a fraction, so I'm going to have to rationalize this. So I get 10 radical 10 over 3 radical 100, right? 10 times 10 is 100. What is the square root of 100? That'd be 10. So I get 10 radical 10 over 3 times 10. Right? That 100 becomes a 10. And then I can just cancel out those 10s and get radical 10 over 3 as my final answer. And I'm going to rewrite that a little more neatly. Forgive me. Radical 10 over 3. All right, so let's check 14 and see if that is right. And indeed it is. So it's like we're taking what's given in the problem. Let me pick a different color. Let's go yellow. What's given, and we're using that to construct a triangle. Then we're looking at the question and using the triangle information to answer the question. So that's kind of the general strategy here. Number 16. So again, I need to start with a triangle. So there's my right angle. Call this theta, hypotenuse, opposite, adjacent. We are given cotangent. Cotangent is adjacent over opposite. So this is 3, this is 4. The question is asking for secant. Secant of any given angle is hypotenuse over adjacent, right? Why am I having trouble remembering, stupid brain? Secant, hypotenuse over adjacent, yep, right there. So for this one, hypotenuse over adjacent is going to be something over 3, but I need to calculate what that something is. So if I call this A, this B, hypotenuse is always C, a squared plus b squared equals c squared. 4 squared plus 3 squared equals c squared. Yesterday I mentioned a 3, 4, 5 triangle, and that's exactly what this is. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. You square root both sides, the square root of 25 equals 5. So the hypotenuse equals 5. 5/3 is the answer to number 16. Where is it? There we go, right there. So it's called a 3, 4, 5 triangle because the sides work out to be 3, 4, and 5. Okay, number 18. Find secant of theta if tangent equals 11 over 2. I keep saying pi. I don't know. You know what? Since every problem involves a right triangle, I'm going to save myself a little effort. So this is hypotenuse, theta, opposite, adjacent, and I'm going to use the scissors, whatever that's called, and duplicate and drag that down for number 20, and duplicate and drag that down for 24, and I guess that's the end of the worksheet. Okay, so number 18, we are given tangent. So in other words, we are given SOHCAHTOA, opposite over adjacent. We are given the opposite and the adjacent. So the opposite is 11, the adjacent is 2. We are asked to find secant. Secant of theta is hypotenuse over adjacent. So our answer is something over 2, right? The adjacent is 2. We need to calculate the hypotenuse. So if we call this A and this B, the hypotenuse is C. 11 squared plus 2 squared equals C squared. 11 squared is 121. 2 squared is 4. 121 plus 4 is 125. Square root both sides. Now, is 125 a square number? No, it's not. So what am I looking at here? I need to come up where I have a little more room to work. The square root of 125. Now, 125 is 25 times 5. So when I square root 125, I'm square rooting both of those. And the square root of 25 is 5. So C works out to equal 5 radical 5. I put that up here. And there's no radical on the bottom, so that's good. That is simply the answer. 5 radical 5 over 2. Oh, and okay, that froze. So let me do this again. Let me scroll down and check number 18. 5 radical 5 over 2. Looking good. A couple more and we're done. Cotangent. Find cotangent of theta if sine of theta equals square root of 5 over 5. Sine is opposite over hypotenuse. So the hypotenuse is 5, the opposite radical 5. We're asked to find cotangent. Cotangent, the ratio is adjacent over opposite. So to answer this, we need something, the adjacent, we don't know what that is, over the opposite, which is radical 5. So here we go. I'll call this A. I'll call this B. Hypotenuse is C. So radical 5 squared plus B squared equals 5 squared. When you square a square root, they cancel, so you get 5 plus B squared equals, oh wait, that was kind of dumb. I should not have put C squared there. C is a 5. I should have put 5 squared. Sorry about that. 5 squared is 25. Subtract 5 on both sides. B squared equals 20. Square root both sides. B works out to equal radical 20, which we can simplify, right? 20 is 4 times 5. So when you square root that, the square root of 4 is 2. 2 square root of 5. So I get 2 square root of 5 over 5. Now you look at that, and a couple things happen. You might say, oh, can't have a square root on the bottom. But even before we consider that, square root of 5 over square root of 5 just straight up cancels. And we get 2, and there is no more square root on the bottom. So the answer, number 20, should just be 2. Indeed it is. Now, you could argue, well, a trig function is supposed to be a ratio, and that's a whole number. So I guess if you wanted to, you could call it 2 over 1. So you got your adjacent over opposite. But frankly, even in trig, even though they're known to be ratios, if you get a whole number, you just call it a whole number. All right, last one, number 22. Find sine of theta if tangent is 3 over 4. So tangent, which is given, is opposite over adjacent. So the opposite is 3, the adjacent is 4. We're asked to find sine. Sine is defined as opposite over hypotenuse. So our answer is going to be the opposite, which is 3, over the hypotenuse, which is unknown. Again, we have a 3, 4, 5 triangle. I know this is going to be 5. The answer is 5. So we get 3/5, and there it is. If what I just said confused you and you're angry at me right now, let me go back and show you the work in case you just don't like the shortcut. So we call this A, this is B, the hypotenuse is C, it's unknown, right? I'm going to erase this, pretend like I didn't know that. So 3 squared plus 4 squared equals C squared, Pythagorean theorem. 9 plus 16 equals C squared. 9 plus 16 is 25 equals C squared. Square root both sides. The square root of 25 is 5. So the hypotenuse is 5, which means, wow, my handwriting. Put a 5 here, 3/5 is the answer. All right, going to stop it there. Do the odds, please, just as I did the evens, and contact me if you have trouble or need help. Otherwise, I will talk to you sometime.